Welcome to Get Your FRQ On. This question is from 2021. It is question 6, and it is not calculator active. In the question stem, we have a patient receiving medication. We have a function, y equals a of t, that gives the level of medication in the patient's body. And we are given that the function y equals a of t satisfies a given differential equation. In part A of the question, we are asked to sketch the solution curve to the differential equation that goes through the point 0, 0. All right, the first thing you're going to want to do if you have to sketch a solution field or a solution curve to a differential equation on a given slope field through a given point is make sure you go through the given point. So the first thing you're going to want to do is graph the given point. In this case, it's 0, 0. Notice it's down here. Once I have that point, all I really need to do now is just be true to the slope field. So sketch something that matches what the slope field indicates it ought to look like. Don't go beyond the boundaries of the slope field. Don't put vertical lines somewhere if the derivative is undefined there. Don't draw anything that is obviously wrong. That's what you want to avoid. You need to be able to make the case that the curve you have fits. All right, so something like this should be fine. All right, the curve is going to look something like that. It's not obviously wrong. Notice I do have horizontal slope field behavior at what looks like x equals 12, and I approach that as if it's a horizontal asymptote, which is what you would expect. Don't do anything that's obviously wrong. In part B of the question, we are asked to interpret the limit expression, the limit as t approaches infinity of a of t equals 12, in the context of the given problem and to provide the correct units. So basically what this limit expression is saying is if the patient is on the medication forever, the limit as t approaches infinity of a of t is equal to 12 would mean that the patient would have 12 milligrams in this case of the medication in their body consistently. So the limit as t approaches infinity of a of t equals 12 means as time goes on, the level of medication in the patient will approach a stable level of 12 milligrams. In part C of this question, we are asked to use separation of variables to find the function y equals a of t with the initial condition 0, 0. So using separation of variables and the given differential equation, dy dt is equal to 12 minus y all over 3. So if I divide everything by 12 minus y, I get dy over 12 minus y equals 1/3 dt, and now we just integrate both sides. Integrating both sides gives us negative natural log of 12 minus y equals 1/3 of t plus c. Doing a little bit of simplification here, the natural log of 12 minus y is negative 1/3 of t minus c. All right, simplifying a bit more and using the initial condition, if t is equal to 0 and y is equal to 0, doing some exponentiation, 12 minus y is equal to e to the negative t cubed minus c, and so y is equal to 12 minus e to the negative t over 3 minus c. And then using that initial condition, we can eventually solve for c, or e to the negative c, that's 12, and then rewrite a of t using the known values. Y is equal to 12 minus 12 e to the negative t over 3 would be the function a of t. In part D of the question, we have a second patient also receiving medication. There's a function there that describes the level of medication in that patient. That's y equals b of t. And we are given that b of t satisfies the differential equation dy dt equals 3 minus y over t plus 2. And we are asked to use this information to determine if dy dt is increasing or decreasing at the point 1, 2.5. Well, in order to determine if dy dt is increasing or decreasing, we have to know the derivative of dy dt. So we have to find d squared y dt squared. So we're going to differentiate our dy dt. This will require use of the quotient rule, or perhaps the chain rule. There's other ways to do this. Quotient rule, I think, is the easiest way to handle it. We get the opposite of t plus 2 times dy dt minus y over t plus 2 squared. So the second derivative, when t is equal to 1 and y is equal to 2.5, we can find by substituting in those values. We have 3 times dy dt when t is 1 and y is 2.5 minus 2.5 all over 1 plus 2 squared. Do some arithmetic, simplify, and we get eventually that d squared y dt squared at the given point is negative 4/9, which is negative, that is less than 0. So if the rate of change of the medication in the second patient is negative at t equals 1, that means the amount of medication is decreasing at that point. So because the second derivative is continuous, on this interval you can check there's no discontinuities for dy dt except at negative 2, but we don't care about negative 2. The second derivative, same issue. We're not going to have any discontinuities except at negative 2, but we don't care about negative 2. It's not anywhere near us. So because it's continuous on that interval that contains 1 and it's negative, we interpret that to mean that dy dt is decreasing at 1, 2.5.